Hello everyone, so this is our second video on MATLAB fundamentals. We'll solve two problems in this lecture. The first problem is quite straightforward. You just have a function which is x cubed sine squared of 3 pi x, and you have the input x and for which you have range -1 to 1, and you have its size of 0.01. You have to find out one thing, that is in this function, for putting the values of x you will get the values of y. So you have to figure out how many values are greater than 5 and what are those, and you have to show them on the graph. So let's generate our MATLAB code. The first thing first is that you have to put the values of x. So the idea is here the -1 is the starting value, and here the 1 is the end value, and the in between value 0.01 is the step size. So you can give input this way for the x values, and the line space that we did in the first video generate values in between, and you just actually give the number of values you want to generate, and in this way you actually say the step size. Okay, next code, the function. You just so to make things power, you just use this caret sign maybe, and these points because x generates the matrix and we want piecewise multiplication, that's why we're using points here. Next, sine squared. Here there is another squared function for which we have given a point here and a point here, and we have a square sine squared, that's why you have a caret and 2. So this is the output function. Now the thing is that you have to plot the input versus output, right? So this is the thing: x, y. X is your independent variable, y is your dependent variable. You have told the line width to be 2. Next, we'll find out the values which are greater than 0.5 for values of y, and for that under variable k we will store the values which are greater than y. Then we will this length of k, by this you'll actually know how many values are greater than 0.5. We are using hold on thing because we want the plotting. First plotting is the output and output versus input. Second plotting is we want to actually mark the values which are greater than 0.5 for step size 0.01, right? So we are plotting the next thing, which is x of k and y of k, right? And we will demark those points using this a 0 sign. I think that is not 0, that is O, however. So let's actually do the coding in MATLAB. So this is our problem 2. We can run it, but before running you have to make sure that the directory it is showing you have connected that in this current folder, but it's not connected. You can see that it is system2, but it is actually like under MATLAB folder we have this M file, so you have to connect the M file, right? So for that you can browse for folder. I have kept my M file in documents, MATLAB, yeah, in this folder. So you can see that my folders now have been connected. So now I can run this. So here you can see that I have a function here, and I have some demarcation, right? So these are the values which are actually greater than 0.4, 0.5, which are greater than actually 0.5. So you can actually give another command like code that is actually grid on. I think now it will be easy to visualize, like it is 0.4, that will be like somewhere 0.5, that is 0.6. So these are the values which are greater than 0.5, and you can actually count them 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 points. You have to keep in mind that the graph has been actually drawn for a step size of 0.01, right? So this is one thing. You can add lessons and other things which I didn't hear. So this is the problem 2, where we had a function this, and we plotted that. Then we actually found out the values which are greater than 0.5, and we showed that in the graph. Now let's move on the third problem. Our third problem says that we have a function of velocity of a free falling bungee jumper. We have the equation, we have some parameters like velocity, then acceleration due to gravity, CD, which is C sub D, which is actually drag coefficient. You have time, and you're given the mass, which is 68.1 kg, and you have a drag coefficient of 0.8.225 kg per meter. Here you have to actually consider the time interval of 0 to 20 seconds, and you have a step size of 2 seconds, right? So let's do that. So first of all, our input is time, right? It will actually start from 0 to, and it will end at 20 seconds, and we have a step size of 2 seconds, right? Next, you will actually build the output function, which is this. You actually write sqrt for square root, and you have the z value, which is 9.81. I put the value directly rather than actually naming another variable, and you have a mass of 68.1, which is told in the question, and CD was 0.25. Then we had hyperbolic tangent. We wrote that, and you have another square root. We wrote that. Then we had the thing, these square root things will be multiplied by t. We did that, and you have to keep in mind that we used this point here also, but it is not actually needed because it does not either square root or squared or anything. So you can give it, no problem, but it's not needed here. Next thing is that we'll plot the velocity versus time, and we'll actually demark the inputs with this sign. We have a title, which is velocity versus time. We have a label x leveling, which is time in second. We have a y leveling, velocity meter per second. We want the grid on. That's it. The coding is quite easy because it's just the beginning. And for that, we will actually run the problem free code. So yeah, that's the thing. We have 0 to 20 seconds with a interval of 2 seconds or sequence of 2 seconds, and we're putting the values for every 2 seconds, and we're getting the graph. And we have x leveling, y leveling, and title. So the thing is that these things are quite easy, right? And it's much easy to learn. Next we'll actually move on more complex problems like solving a bisection problem, a Newton-Raphson method, this kind of things, integration, differentiation soon. So it's a term.